All right. So today's class will talk about 3.3 and 3.4. So Karishma, if you have any questions, you can always chime in and ask for any questions you have. And then we look, and then I'll tell you what's going on in these two sections. After that, we look at your homework. Okay. So mostly what we did in 3.3 and 3.4 here is we are talking about polynomial functions. Okay. So last time in 3.1, we also talk about polynomial function, but it's quadratic function. That means we talk about ax squared plus bx plus c, the function equals f of x. So this is easy to do at 3.1 because you can find the zeros and you can find the x-intercept and everything by factoring or by quadratic formula. But now the polynomial function here is given us by axn, bxn minus 1, and then plus till whatever z is, the last integer. So now what we have to do here is the polynomial function is very difficult to find the zeros. Okay. So mostly the main part of this section 3.3 and 3.4 is to find zeros. Zero is the same thing as finding the x-intercept, finding the solution, or finding the factor. They're all the same thing. Okay. Now, given you a quadratic function, it's very easy for us to find the zeros or the factor or solution. Either you can factor it, or you can use your quadratic formula. Okay. However, now we are talking about 3.3 and 3.4 here. So in order for us to find the zeros for 3.3 and 3.4, because if you have a power 3, you will have at least 3 zeros. So when I say the word at least 3 zero, it means that it can be no zeros, 1, 2, or 3 zeros. So these zeros can be real, or it can be complex. So you have to be careful. So 3.3, everything we talk about that is all about real. And then 3.4 is where you talk about the complex. And when we talk about complex number, is the a plus bi. Okay, so that means that so when you have a power 3, you got 3 zeros. It can be real or complex. And when you have a power 4, you will have 4 zeros. And when you have a power 5, you have 5 zeros, and so on. Again, zeros are x-intercept, solution, or factor. So in order for us to find these zeros, you cannot factor it. You cannot use quadratic formula. You can only do it when you have power 2. But once you reach the power 3, 4, 5, you cannot do it. So what we're going to do in this section here is we have to find the zeros. So what happens when you have a power 3 is if you can find one of the zeros, the power 3 will become power 2. And then the power 2, we can find the zeros using factoring or using quadratic formula. Same thing happens when you have a power 4. You have to find 1 0 to make it power 3. And then another 0 to make it power 2. And then once you reach the power 2, you can use factoring or quadratic formula to find the rest of the zeros. So when you have a power 4, you find a 0, and then you find another 0. And then when you have a power 5, you have to find 1 0 first to make it power 4. And then to make it power 3, you find another 0. And then to make it power 2. And then you factor. Now, in order for us to, so you continue so on. So finding this 1 0 that we have here is painful. This red box that I draw here, this is a painful job. This is easy job because we really learn how to factor in use a quadratic formula. But finding this 0 is difficult. And in order for us to figure out if they are 0, when you do the long division, your remainder has to be 0. So we do not want to do long division here because long division is super tough. So what do we do to replace long division is we perform syntactic division. So that's why when you look at 3.3, the first few questions that they ask you is to perform syntactic division. This syntactic division is to teach you how to find your remainder and how you find your quotient. Okay, so for example is when you do a long division, this is what we call as a dividend. This is what we call as a, this is called as a divisor, sorry. This is called as a dividend. And when you got the answer up here, this is what we call as your quotient. And then when you divide and you subtract and so on, the last piece you have is your remainder. And for you to have a 0, this remainder has to be 0. So performing long division, you have to do what we call as trial and error, because not every time when you divide with a divisor, you always get a remainder of 0. Okay, so if your remainder is not 0, you have to change your divisor again. So in other words, this is what I usually tell my students. If you want to perform a long division, and you want to divide this with x minus 2, just for example here. When you want to divide this by x minus 2, that means that your 0 in this case, you figure out is it 2 or not. And how do I get 2? You set this equals to 0 and you solve for x. That's why. And you have to do long division here, which is a lot of work. And if your remainder is not 0, then x minus 2 is not a factor, or in other words, 2 is not a 0. And what you need to do is you have to change this with another number, let's say 1. And you have to repeat this again until your remainder is 0. So that's the reason why that this 3.3 and 3.4 is tough, is because you have to keep on trying this countless of time until you reach your remainder is 0. But doing long division is something that I do not want to do it. So I need to teach you how to do the syntactic division. So Karishma, do you know how to do syntactic division? It's fine if you say no, I can teach you.
No.
Okay, fine. So if you see anything about long division, do not do it because it's going to be not good. So not good, it's just a lot of work. Okay. So what we're going to do now is I'm going to teach you how to do a syntactic division, because the syntactic division will be replaced by long division. Okay. So I'm going to teach you. So that's the reason why we don't do the long division here. Too much work. So a syntactic division. So there are some rules you need to know. The first rule is your polynomial function has to be in a standard form. What is a standard form? Standard form means that your power should be from high. You have to arrange your power from high to low. So that means that you have to have a power 3, then power 2, then power 1, and then a constant term. Okay, so you have to arrange them from high to low. If it's not arranged, you can your syntactic is wrong. 2, if there is a missing term, you have to slot in the 0 as a placeholder. What is mean by missing term? For example, is if you have 3x cubed minus 4x plus 8. So you notice that the missing, you got cube, you got power 1, and you got a constant. You find out there is a missing square term. So you have to add the 0x squared. This 0x squared is called the placeholder, which is called a missing term. Again, without this, you also get wrong. So you have to first put them in high to low power, and any missing term you have to put in 0. And thirdly, your divisor can only take form as x minus k. That means this x has to be power 1. Okay. If you have x squared minus any number you want, or x cubed or something else for your divisor, then you cannot use syntactic division. So that means this divisor that I'm talking about here has to be x minus k or x plus k. Then you can use syntactic division. But if you have a x squared or x cubed on here, then you are not allowed to use syntactic division. Then you have to use long division. So that's why in this, we don't talk about that because we try to avoid long division. It's a lot of work. You can also use as ax plus minus k. That means that if you have a number in front like 2x minus 1 or 3x minus 1 or 3x plus 5, you can still use it. So all this is good. Okay. So how do you do your syntactic division is first, you have to figure out your zeros here. And your 0 is taking your divisor, make it equals to 0. So for example is, let's say you want to divide this by x plus 5. So this x plus 5 is your divisor. So what you do is you make it equals to 0 and solve for x, and you get -5. So your 0 in this case is -5. So this is how we do this case. And then the next one we have is the list of all the coefficient. Coefficient of your polynomial. Coefficient means the number. So if I want to divide this with x plus 5, for example, using syntactic division, the first coefficient we have is a 3. Because there is no x squared term, you have to put in a 0. The next coefficient is a -4. And the last coefficient is 8. So that means that this is power 3, power 2, power 1, constant, no x. Okay. So what you do next is, this is how we do syntactic division. There's always a blank right underneath it. So the first thing you need to do is this number 3, you drop down. And then you multiply the 0 with what you have. You put it underneath the next line, or the next column. So -5 times 3 is -15. And then you always add these two up. So when you add these two up, you get -15. And then you repeat again. You take your -5, which is 0, multiply with -15. That will give me 75. You have to use your calculator. Okay, so 2 negative become positive and it becomes 75. And then what you need to do here is you have to add these two, you become 71. And the last thing you do is you take this 71, multiply with -5. Yep, you need calculator. This is gonna get big. Let me check this one. 15 times 5. Yep, 75. Now I need to multiply with so now I need to take 71, multiply by -5. That will give me -355. And then you have to add these two up. So -355 plus 8. This is -347. Karishma, are you following so far?
Yes.
Okay. So so what we're doing here is you drop the first leading coefficient, and then you take the leading coefficient, multiply with the 0 that you found early on from the divisor, and then you add again, and then you multiply, add. You keep on doing this until it ends. Here in this case, it ends. So once it ends, the one that underneath here is the important piece. This number that you found is your remainder. And the one that is under the one next to the remainder, these whole three of them, this is your quotient. So remember last time when I say quotient, quotient is this one, right? When you divide something, you got your answer. That's your quotient, that's your answer. And then you always, sometimes you got a remainder, right? And you can tell this remainder is not zero, right? Because you want the remainder zero. So since your remainder is not zero, then we can tell that this x plus 5 is not a zero or x-intercept or solution or factor. So you can tell that this x plus 5 is not the factor or solution in this case. In order for you to have a solution or factor or x-intercept so on, this remainder has to be zero. And how do we write this quotient? We write back as a polynomial form. So what happened is, because this is a power, you start out with power 3. So when you perform a syntactic division, you will get power 2. So you get 1 degree less. So if you start with power 4, then you end up with a power 3. If you start with power 3, you start with power 2. So what happened is that this 3 will become x squared. The negative 15 will become x, and then plus 71. So what happens in this case is, this is your quotient, which is supposed to be written down here. And then your remainder is minus 347. This is your remainder, over by the one that we divide here, x plus 5.
Where did the x squared come from?
The x squared come from here, because remember this is x cubed, right?
Okay.
And then this is x squared, this is x, and then this is the constant term, right? So when you do a syntactic division, all the next line here, the one down here, all will be reduced by 1. So the x cubed will become x squared. The x squared will become x. This will become number. And then this one will become the remainder. And it's always like that. So that means that if you start with an x4, so on, and then when you perform a syntactic division, this one will become x, whatever number you get first is the x cubed, followed by x squared, followed by x, followed by a number, and then you end up with a remainder on here. Okay. You with me here, Karishma?
Yeah.
Yep, it's always like that. So no matter, depends on where you start. So if you start with x5, and when you perform the syntactic division, you will end up with an x4.
Okay.
And then you have to perform another syntactic division, end up with x cubed. Right. Okay. And then you perform another syntactic division, you perform x squared, and then you find your zeros. So this is why it's so difficult. It's because if I give you x5, you have to perform 3 syntactic division. And all these 3 syntactic division we have, your remainder has to be 0. And if like this case, your remainder is not 0, you have to try again with another 0. That means -5 does not work. So you might have to try 1 or 2 or 3, or even fractions, 1/2, or even square root, or even complex. Yes, your syntactic division can perform with zeros that is any number. Real numbers, square root numbers, pi, 3i, complex, anything you want, you can put in here and you still can perform a syntactic division in this case. So this, the difficult part, like what you did here, this is what you found in 3.4. So right now, 3.3, we are doing a nice number like this.
Okay.
Okay. So with this, I want you to try to do a syntactic division on your homework. So when you look at your 3.3 homework, they want you to use a syntactic division to divide, like number 1. So Karishma, go ahead and try to do this question number 1, and I will try my best to show. There you go. This is a syntactic division. So try to use a syntactic division to do this. So make sure you understand the requirement. The first requirement is this polynomial in standard form, Karishma? Is that high power to low power?
Yeah, it is.
So it is a standard form. Do you have any missing terms here?
No.
So that's good. So we don't need to worry about that. And do your divisor, which is this one, has a square on your x or a cube on your x?
No.
So that means that you can use synthetic division in this case. So do you remember how to find your zeros here, Karishma? Remember how I find a 5 here? Negative 5. How do I find negative 5?
From the
divisor, right? The one that we divide with, right?
The divide.
It's fine. Don't worry about that. So can you tell me what is your zero? What is your number you have to divide here?
-4.
No. Again, this is a plus 5.
Oh, so 5.
No. Hit this one.
4. Sorry.
Yes, 4. Yes. So that is 4. I'll do right up here. What is your coefficient you have to put in here? Remember last time I put 3.
So you have to put 9.
What else?
And a 0.
No. Look at this is your question. This is your question.
Okay, so you put the 9 and then you put the 41.
With yes, no negative, you get it wrong. Okay, next.
And then you put the 29.
Followed by?
-36.
Very good. So this is how you start doing your synthetic division. And you have to practice this because if you don't know how to do this, you cannot do 3, 3, and 3, 4. How do I get this 3? I just dropped this one, right? So what you do?
You have to drop the 9.
Very good. Then what you do next?
And then you multiply the 4 with the 9.
Which you get?
36.
And then what you do with these two numbers?
You add it.
Okay. What's the addition of these two? Use your calculator if you need to.
-5.
Yep. And then multiply again with 4.
Multiply the 4 and the -5.
You get what?
-20.
Add this one up.
And then it'll be 9. And
multiply these two.
36 again.
And what you get? This is easy. Negative. Don't forget we are adding. You always add here, not subtract.
Oh, yeah, I got 0.
You get 0. Yes. Don't forget we always add. A lot of students subtract. And what's the meaning when what is this 0 stands for? That is your
remainder.
Remainder. And this is good news. If your remainder is 0, means x minus 4 is the factor or is the x-intercept or solution or 0. That means this is your 0. So that means that when you look at your graph, this graph will cross at 4 on the x-axis.
Okay.
Because your remainder is 0. Now, can you tell me what is your quotient? Remember the quotient that we talked about here?
Okay, so That would be, so would it be 9 x squared minus 5x plus 9.
Now, if your remainder is 0, you do not need to put this icky stuff back.
And then that will be your answer.
This is your answer. And this is where you're going to type in here. You got it?
Yeah.
So it's a practice. You have to practice this. And as I told you, 3234 is a very heavy on this syntactic division. Do you got how to perform syntactic division now?
Yes.
Do you want to practice another one?
Can we try the one that's not in order?
Okay, that's good. Let's try number 6 yourself. Go ahead and do it yourself.
Is that a 5?
6, number 6.
No, like the number, like in the parentheses in the front.
Missing one. Then try number 8 then.
Okay.
Number 8. Try number 8. So this is question 1, number 8.
Can we do number 6?
Number 6. I mean, yeah, you pick one and you do it.
Okay.
Which one you want to do? 6 or 8 or?
No, we're gonna do number 6. Sorry.
Okay, do number 6. Okay, then you do number 6.
Okay.
Because I don't know which one you're gonna in your homework. You're gonna do everything actually, but so you do number 6. And then you tell me what answer you get. I'll do number 6, same number 6 here.
Okay.
And I'll tell you, and then if your answer is correct, I'll say it's correct. If your answer is wrong, then it's wrong. You have to try again. Your homework is different from this question, so that's fine. This is my homework actually, so make sure you use your calculator. Karishma, make sure you follow these 3 steps, because if you don't follow these 3 steps, no matter how correct you do your syntactic division, it's going to be wrong. So make sure you know it's standard form, missing term, and then your divisor has x power 1. Usually the 3rd step, you do not need to worry about it because usually it's power 1. These are the 2 things that usually that you got to watch out for. Can you tell me what just tell me what remainder you get? Because remainder is the most important. If your remainder is wrong, then everything you do is going to be wrong. So for number 6, just tell me the remainder first before you tell me the quotient.
for my remainder, I got a 0.
Very good. That is correct. Now, can you tell me the quotient?
Okay. Sorry. Okay, it's going to be 5x squared.
X what? I'm sorry.
5x squared.
Uh-huh.
And then since it's going to be a 0.
So ignore it. You do not need to write anything with it.
Okay, so then wouldn't it just be minus 15?
That's it. This is your answer for number 6.
Okay.
Are you all right?
Yeah.
So I think you know how to do synthetic division now since you do this.
Yeah.
Now, I'm going to refresh this. I have to start a new one. Do you need to take a picture of this before I start a new one here?
I wrote everything down already.
Okay, so can I get a new piece?
Yes.
Okay, so what I want to point out to you here is if I this is for 3.4 and this is also your test. And let's say I give you this f of x equals to, but it's nicer, it's more like a already in a standard form, so you do not need to switch them around. Okay, so if I give you this and I want you to find zeros, so what you do here is you have to perform the syntactic division like what you did just now.
Okay.
And you find out that this 6 you put here, right?
Yeah.
And you got the 0 here, right? And you got the 5 and you got the 0 and the negative 15, right? This is what you get, right?
Yeah.
So if you want to find the zeros, 6 will be one of your zeros.
Okay.
But do not forget, when you have a power 3, how many zeros do you need to give to me? You have to give me 3 zeros. Whatever power you have to give, but you only provide how many? 1.
Oh,
So
yeah.
now my question is, what is the other 2 zeros? And you also see in this section. So what do we do here is, pay attention, Karishma. What you got left over here, which you told me is what? 5x squared minus 15, right?
Yeah.
You set this equals to 0.
Yes.
And then now, because this is a quadratic, it's a power 2.
Okay.
We can find this other 2 0 using this equation by either factoring it or by using quadratic formula. But I want to tell you that if one of your term is a 0 term, I will recommend you to factor it because it's very easy. Okay, so since this term, middle term is 0 or the last term is 0, so if one of this term is 0, I will recommend you to factor it. So what can you factor out in this case? What is in common between 5x squared and 15?
You could divide it by 5.
Wait, yes, you can take out the 5. You're correct. Or divide by 5. So what happens when you take out the 5 and divide by 5? You get x squared minus 3. So this is equals to 0. Now this 5 has no x on it, so you cannot solve it. If there is a 5x, then you have to make it equal to 0. But this one left over has an x, so this is x squared minus 3 equals to 0. And now we need to solve for x, so I just moved the 3 over. So I got x squared equals to 3. And how do we get rid of the square? We put a square root. And when you have a square root, you got plus and minuses. So that means this have how many answers here?
2 answers.
2 answers. So that means your 0 in this case will be 6.
And 3 and negative 3.
Root 3 and negative root 3. So this is your answer here. And this is coming up in later on, 3, 3, 3, 4, and then in your test. So you have to do all this work. And this is what happens when you have power 3. Do you know what happens when you have a power 4?
You have to have 4 zeros.
You have to do the syntactic division. Let's say again 6 example. You get 0. And then whatever left over here, you have to perform another syntactic division. Because when you have a power 4, when you perform a syntactic division, this syntactic should become power 3, right? And you cannot factor or use quadratic because they're only used for power 2. So you have to do another syntactic division, let's say -1, and it becomes 0 as a remainder. Then this will become x squared, like what we did here. And then you repeat what you just did here. Is either you're going to factor this or you're going to use the quadratic formula. So your 0 in this case will be 6, -1, and whatever 2 answers you will get from using factoring or quadratic. Yes, when you use a factoring and quadratic formula on x squared, you always end up with 2 answers. You with me here?
Yes.
So with this, we can try to do like question number, this one. Question number 15. It says that use the let's do 16 because it's half, it's 1/2. Use the syntactic division to show that 1/2 is the solution. So when they say 1/2 x, which is 1/2, half is a solution, means that when you do syntactic division, your remainder is 0. And then after that, use the result to factor the polynomial completely. So what they mean by that is once you use this, then they want you to factor it out. Instead of using quadratic formula, they want you to factor it out. And then once you factor it out, you give me the real solution. So like if I give you this answer, the answer in this case will be 6, √3, and -3, You see that? So this is what you have to, this is something like question 16 we are doing here. You with me?
Yeah.
Okay. So, but we're gonna start. We're gonna do a fresh one here. So we're gonna do exactly 16 because this is just a scratch of it. So so let's do 16 here. So so now I'm gonna teach you how to use fraction here, and don't worry about that. It's just a fraction. Okay, don't like ooh scary. So I'm gonna do a new one so you can see it. So so number 16 now. So go ahead, I'll do syntactic division by half. And this one, since they give us 0, you do not need to solve it. Remember last time you had to solve the 6. You know, you do this, make it equals to 0, and you put 6, right? Like that on the previous question that you did. This question, you do not need to do like what you just did because it's given x equals 2, so you do half here. And then this is already in a standard form and no missing term, no missing coefficient. So that will be 2 here, -11, 17, and -6. Same thing happens, you drop the 2. Then half times 2, you know what half times 2 is?
2.5.
No.
No.
Half is 0.5. What is 0.5 times 2? What's 50 cents times 2?
Hold on 1 second.
What's 50 cents plus 50 cents?
What's $1?
$1, yes. Now you add this, what you get?
You get -10.
And what is negative 10 times 0.5?
5, negative 5.
Very good. And add 17, what you get? Forget you add these two up.
12.
Multiply it again with 0.5.
6.
And add these together.
0.
Very good. So this is good because it's already shown that this is the solution because your remainder is 0. If your remainder is not 0, you have to recheck your syntactic division again. So can you tell me what is your quotient in this case? Remember the leftovers?
Okay, 1 second. So it will be 2x squared minus 10x plus 12.
Perfect. Now equals to 0. Now you need to factor this fellow.
So don't you subtract the 12?
No. Get rid of, can we reduce these numbers?
Oh yeah, you could reduce it. You could divide them by 2.
Make it smaller. Yes, if you reduce them. So you get x squared minus 5x plus 6, right? Equals to 0. Now, what is the factor for this case? X squared is x times x.
It would be so wouldn't it be like negative x minus 2 and x minus 3?
Perfect. Yep, that is correct. And you every time when you factor, you want to check if it's correct, you just for it. When you for it, you got back the one on top. So can you tell me what is your solution in this case? Your answer here?
Negative.
Make them equal to 0. Don't forget to make them equal to 0. So what happens when you make this become 0? X minus 2 becomes 0. X is what?
Minus 2. Wait. No.
Come on. Karishma, I should know this. This is not that tough. You already read that? You already got the answer is popping up here. X is what here?
2.
What else?
And 3.
What else? You forgot something. Do you remember the 1/2?
Yeah.
That's where you put it here.
5.
So this is your answer in this case. So again, this comes from here. This comes from, don't forget you divide by half here. So that is your solution also. So this is how you put your answer here.
Okay.
You got what to do?
Yeah.
Now, what we did in 16, because it's a power 3. Okay. So if you look at 17, it's the same thing. So the good news about 17 is they already give you 2 factors.
Okay.
So what you do is you perform a syntactic division on x plus 3. So go ahead and perform syntactic division on x plus 3. They kind of do it partially already, so you can fill in the blanks here. So this is the function. So they do x plus 3.
Okay.
So which is -3 here. So there's a lot of syntactic division on these two sections, nonstop. You know what? Just do it on your own. Don't look at. So don't look at what is. Just do it on your. It's easy to do it on your own. If you look at it, it's even worse. This is 2. So Karishma, what you get? Have you done that? Are you doing it now?
Yeah, I'm doing it.
Perfect.
Okay, so I got 2 and
just give me the bottom number.
okay, so 2, -5, and 2 and 0.
Perfect. Very nice. And then now we do the x minus 2. This
So
one.
2.
So this is very good too. And your coefficient is still the same. 2, 1, -13, and 6, which comes from this function. And then again, you drop the 2. I want you to perform the syntactic division again, but this time with 2. It's a lot of syntactic division. Yeah, the test is so you will do a lot of this.
Okay, I got 2, 5, -3, and 0.
Perfect. Nice. Now, so this is how you're going to fill in the first part. This is called a verifying that this is a factor. And in order for us to verify it is a factor, your remainder has to be 0. Okay. And this is how you do it. Part B is asking us to find the remaining factors. Now, you know that this is a power 3, right?
Yeah.
How many factors do we have in power 3?
3.
3. And the question already provide you 2.
Yeah, so you have 2.
You have to find the other one.
Okay.
And how do you find it? Is either you take this fellow or this fellow, one of those, and you have to what?
Factor it out.
Factor it. So which one you want to pick? One of them, they are the same. You will get the same.
The first one is fine.
The first one. Okay, can you write this for me in the quotient form?
Okay.
Like what we just did over here.
So it's 5x.
So it's 2x squared.
Minus 5x plus 2.
Okay, very good. Equals to 0.
Equals 0.
Yep. Now, this factor is not as easy. You cannot divide by 2 like what we did last time because 5 cannot divide by 2. So you have to do this.
The quadratic.
You can use quadratic or you can actually factor straightforward.
Oh, you can?
And yes, you can. And I can tell you that one of these answer is him. Why? Because this is a factor. So if you pick this, the other one, then your one of the answer when you factor should be x plus 2. Okay, so that's why you pick this one. So you use this. If you pick that one, then so can you tell me what times x give us 2x squared? What x times what give us 2x squared? No, you're kind of doing 4 in here. X times
x times 2.
So 2x, x times 2x gives us 2x, right?
Yeah.
Can you tell me negative 2 times what gives us positive 2?
Another negative 2. Oh, a negative 1. Sorry.
Perfect. Yep, you're fine. So yes, this is the factor for him. So when you FOIL this one out, you will get him. So that's the reason why that although it looks tough, but already given you a factor here, so you use that for your help. So can you tell me what will be the remaining factor for part B? You got x plus 3 here. We got x minus 2 here. So the remaining factor here is what?
So wouldn't it be 3?
No. This one.
Oh, sorry.
So this answer will be 2x minus 1. That is your remaining factor.
Oh.
Because you already know x plus 3 is a factor. You already know x minus 2 is a factor. So you already know these two. So that means the leftover, the remaining one is this one. Okay. Next, questions part C. Write your answer in the complete factorization of f of x. So when I say complete factorization means everything has to be in the factor form. And guess what? How many factors you told me just now? We have
3.
3. So which are what? Which is the factor in this case? One is what?
3.
Not 3. 3 is not a factor.
Oh.
3, negative 3 is a
Negative
0.
3.
But again, don't give me negative 3. That is not factor. That's 0. So negative 3, the factor is what? X plus 3. What else?
X plus 3, and then x minus 2.
And? What's the
minus 2?
What is the remaining factors?
2x minus 1.
Yes. So that means that if they give you, you know, this is the 2 factors and this is the remaining factors. So if I want you to write this in a complete factorization form, so you just take this fellow and those 2 fellow and combine, that's it. That's what we call as complete factorization form. You okay?
Yeah.
And then you have to give me your zeros. Zeros is easy because you just solve for this. So x plus 3, the 0 is what?
Negative, wait.
Now, yep, you're correct. Negative 3. What's the 0 for this one?
2.
Yep. And what's the 0 for that one? Equals to 0. Solve it. Solve for x. If you cannot do it, you just put 2x equals minus 1 equals to 0.
Okay.
Solve for x. And whatever you get, that is your answer.
One a half.
Very good. So this is your answer for D, the zeros. And this is called completely factorization form, C.
Okay.
Now for E, you have to graph this. Now graphing this is easy. I don't say it's hard, it's easy. Why I say it's easy is because you already know your zeros. Because 0 is also the same thing as your x-intercept. So all these numbers that you find in here in D will be on x. So in this case, you get a negative 3. You get 1/2. And you get 2. These are your zeros here. You okay here so far?
Yes.
Now, if you look at your original question here, which is f of x given to us, is given us by 2x cubed, right?
Yeah.
So you can tell what we call as the end behavior that you learned in 3.2. Do you know what the end behavior is? Either it goes up or it goes down or something else like that.
Okay.
So do you know what's the end behavior in this case?
No.
Do you know what is an x cubed graph looks like?
Oh,
What happens on this side? Does that go up or down? Can you draw the graph? Do you know what an x cubed graph looks like? It looks something like this one, right?
So it goes up.
It goes up on the right.
Okay.
And what happens on the left?
It goes down.
So this has the same thing. It's only 2x cubed. So it's the same thing. So here will goes up on the right and goes down on the left. Because it's an x-intercept or zeros. So your graph will go like this, will cross here. And then it will turn. And then it will cross on half. And then it will turn back up to cross at 2. So this is what your graph looks like in this case. You okay there?
Yeah.
So when you have this is 2x cubed, your graph will look something like that. But what happens if your 2x cubed is a negative 2x cubed?
Wouldn't it go the opposite way?
Yep. So you got all these points again, right? The -3, the 1/2, and the 2. So what happened is instead of going down on the left, it goes up on the left. Instead of going up on the right, it goes what?
It goes down to the right.
So this time you will have to go all the way down here, touch this fellow, and then it will turn, and then it touch the 1/2. You not touch, it cross, and then it turns back down and cross that 2. So this is what happens when you have a negative. This is up here and down there. And if you have a positive, it's down here and up there. You with me here?
Yeah.
How high is your turning point? That you will learn in calculus. So in calculus 1, you will learn how tall is this turning point is. This is called turning point, your vertex.
Okay.
But right now, you do not need to worry about it. You just need to know that it's a turning point here, and there's a turning point there. So this graph looks like which graph? The one that we draw, right? Yeah. This is your answer. So which one looks like that one?
The first
one?
Yeah.
Yep, that's correct because it's a -3, 1/2, and 2, right?
Yeah.
This one is not -3. This one is not -3. This one is -3, but this is -1/2. So it's no wrong. Mm-hmm. You okay there?
Yes.
So make sure you practice this because it's this is 3.3 only.
Oh, that's only 3.3.
This is only 3.3, yes. So you have to, I want you to practice this. Yep, this is only like 19 questions. Practice this. It's not that difficult. I mean, you see that it's difficult, but you can do it.
Okay.
Okay. And then the last thing we're going to talk about here in also 3.3 is question 13 and 14. These are the 2 ones that we haven't talked about. Oh, by the way, have you taken a picture or do you write this down? Or?
I wrote it down.
Okay, so I can start a new one?
Yeah.
Okay. So the last 2 questions that we talk about is 13 and 14. So whenever you perform a syntactic division, we call this as your dividend. We call this as your divisor. We call this as your remainder. And we call this as your quotient, right?
Okay.
So remember last time when you do a syntactic division with, let's say, last time we do 6, and then a 5, and then a negative 30. This one I think we did last like quite early. Negative 15 and 90. And then you got 5, 0, negative 15, and 0. This is what you got, right?
Yeah.
So just anything. So when you want to write this in this, what we call as a division algorithm form, f of x equals to x minus k, qx plus r. So how do you write this is x minus k comes from this. This is your k. So in this case, it will be x minus 6. Okay. The qx is come from your quotient. And what is your quotient in this case? 5x squared minus 15. And then you plus 0, which is your remainder. So this is how you figure out this form for question 13 and 14. So for your case, Karishma, I want you to use a syntactic division on -2 for this function. For question 13, I want you to use the syntactic division on this case. Go ahead and do it. There's a repeat, a lot of syntactic division. So you have to do a lot of syntactic division. This is 1. This is -4. -10, 10. And again, you just give me the last row of numbers here. That's the most important thing. If that's wrong, then we'll look at your second row. Drop the 1.
Okay, sorry.
What you get for your last row?
Sorry, I'm still simplifying it.
You're fine. Don't worry about it. Thought you're done, but you're still doing it.
Okay, I get 6 for the remaining. Oh, sorry, I get
the whole thing. I'm sorry, the whole row. You need the whole row.
-6,
Mm-hmm.
2, and 6.
2 and 6. Okay, good. That's correct. So this is your remainder, right?
Yeah.
Can you tell me your quotient here?
It would be 1. Wait, x squared minus 6x plus 2.
Okay, that's good. That's it. You need to tell me that. So now you can write this in the division algorithm form. So x minus k. And what is k in this case? K in this case is the one that you divide with. This is your k. See, that's your k. So what should we put in here? X minus k. So what's k in this case?
2.
-2. So that will become
Positive 2.
positive 2. And then what is your quotient here? The one that you give to me, right? The one down here.
It would be x squared minus
Copy and paste. Yep. Minus 6x
plus 2.
plus 2. And then what is your remainder?
6.
Plus 6. So this is how you figure out your how you do question 13 and 14 is the one that you divide is your k. The one that you find over here is your quotient. And then the remainder is at the back. Now, Karishma, if you FOIL this thing out, and then you plus 6 after you FOILing finish, and then you add 6 here, you will end up getting this function, x cubed minus 4x squared minus 10x plus 10.
Okay.
Okay. And then you also very strange is you can also find your remainder without doing this all this syntactic division. Is by putting your k into your x, f of x. So since your k is -2, so if you put f of -2 inside your x, which is -2 cubed, minus 4 times -2 squared, minus 10 times -2 plus 10. So if you put this k, the one that you divide with, into your x here, you will always get back your remainder. In this case, 6.
Okay.
It's always. So that means that how many ways can we find remainders? If I give you a polynomial functions like this, there are 2 ways. One way is use the syntactic division, like what we did here. And then this is your remainder. Another way is you just plug -2 inside your x or whatever k is given to you inside your x, and you get yourself a remainder. But I want to tell you this method that I just now tell you here is not a good method to do it. The reason why it's not a good method to do it is because you do not know your quotient. Remember last time when you want to find the zeros, you use this quotient and you set it equal to 0 and you factor it out, right? But for this case, although you find your remainder here is 0, but you have no quotient in this case. So that means you do not know what is your quotient. So you have to do a syntactic division. So I will recommend you do not use this method to find your remainder. Use the syntactic division to find your remainder. You with me here?
Yeah.
Because the reason why is because this will give you the quotient. This is the important piece for us. Because then you figure out what is your axis or your factors. But with this, you cannot find your zeros. It's just telling you that. You with me here?
Yeah.
And then for the 14, my advice is change this into decimals. You know what is 1/5 in decimal is?
No.
You got your calculator, right?
Yeah, I have my calculator, sorry. 0.2.
0.2. Yep. So what you do on question 14 is you put 0.2 here, and then you put all these numbers in here. Same thing.
Okay.
Then you use 0.2 instead of 1/5. And then when you, for this part, when you put 1/5 into your x, you always will get back whatever you get the remainder here.
Okay.
So that's what you got here. So this is all in 3.3. So make sure I want you to practice 3.3 first. This is something that you need to know before you move on to 3.4.
Okay.
So go ahead and practice this. The rest is all the same. 19, you just need to do the back. What you do is you just need to get the C here. So on question number 19, when you perform a syntactic division, you put a C over here. Okay. And then let's say you perform all this syntactic division, and let's say you got 5 here. Let's say. Okay. And they already say that when you do this, it is divide evenly. So when they say divide evenly, your remainder has to be what? 0. So when they do divide evenly, your remainder is 0. So now what you do is you set this equation up. C plus 5 equals to 0. And what is C in this case?
Wait, 5.
No, 5.
Wait, -5.
-5. So in this case, so you still do the syntactic division like last time because you got -2 here, you got you do the same syntactic division until you reach into this part. You just need to take this C plus whatever number you have here equals to 0, and then you solve for it. And if you get -5, that is your answer. Okay. So you still need to, this is just an example. This is not 5. This is something else. I don't know what it is. I just give an example. So this is how we do question number 19. You just perform syntactic and make sure that the remainder here is always 0. The reason why is because that's what happens when you say divide evenly. So if you have a fraction, if you have a number divide evenly with a divisor, your remainder is always 0. So that's the reason why that you got 0 here. You okay there?
Yeah.
Okay. So go and practice. This is also do syntactic division. Don't do the long division. Use a. So go and practice this 3.3, and then and then maybe Monday we'll do 3.4.
Okay.
Yeah, because it's gonna be, you need to, and then 3.4 is like even tougher than this.
Okay.
So what you need to do now is soak all this into your brain first before we go 3.4. Because if I go to 3.4 right now, you'll be like completely crazy.
Okay.
So spend some time over here, do syntactic division, a lot of them. Because when we go to 3.4, I will be like, I want you to do this in less than 2 minutes or less than a minute.
Okay.
Yep. So that's why you need to practice this, the syntactic really, really well. But once you go to 3.4, it's like quick.
All right.
All right. So that's it. Try to do this homework, and then after that, if you have any questions, again, email me.
All right. Thank you so much.
We'll start another Zoom on Monday. I think 3:30.
Yeah, that should work.
Yep. So I'll send you a link, and then after that, you just we'll see you on Monday.
All right. Thank you.
All right. So I'm gonna stop recording here and